What do you do when the products designed to help you don't actually work for you? This is a reality for our challenger, Michelle.
Hi, my name is Michelle. I'm 30. I'm studying to become a teacher, and I'm also working at the Bike University Hospital as a peer counselor for other wheelchair users. So 2 years ago I had a spinal cord stroke. Never heard of it before. It's like a stroke you have in your head, but just in your spinal cord. And I'm paraplegic, but I can still walk.
Here we are stimulating Michelle's step without enough foot clearance because of too much pulling in the calf muscle. With enough foot clearance, you can increase your step length and improve your walking ability and become more energy efficient. Currently, there are no suitable products available for Michelle's needs, so she has had to create her own solutions. For example, she has tried stacking books and placing her foot against them to stretch her calves.
I have to step onto the books, and then I get spasticity in my legs, and it makes it a bit harder to actually get my other foot on the books as well. And the biggest problem is that it's not as dynamic. So if I want to release the stretch, I actually have to completely step down from the books. And then after a while, I have to step onto the books again. And that's very bothersome.
She has also tried using a resistance band by placing it behind her feet and pulling while seated.
For that, I actually have to get onto the floor, which is also a workout in itself almost. And as soon as I stretch out my legs, I get spasticity again in my legs. I love testing out new things, especially for people like me that depend on technology and assistive technology. And I just wanted to see what we can come up with as a team, what other people can come up with, just try out new things and connect with other people and tell my story. And yeah, I think that's the reason I wanted to join.
Hello guys, my name is Konstantinos and I'm the project manager of Team Michelle. Let me show you the team.
Hello, my name is Bob. I'm a movement scientist and movement therapist, and I'm the main contact person with our challenger.
Hi again, it's me. I'm Rodrigo and I'm the mechanical lead. And as you can see, I am currently working on the CAD.
Hi, I'm Sabina and I'm the testing and documentation lead. I'm currently working on soldering our sensors. We began our design process by meeting with Michelle to better understand her needs and goals. During this first meeting, we learned more about the physical challenges she experiences, including spasticity in her calf muscles, increased plantar flexion, and reduced toe clearance. She has shared that she had been trying different methods at home, such as using the resistance band while seating and stacking books to stretch her calves, but neither solution was effective or comfortable. From this, we identified key design requirements. The device needed to target the calf muscles, be safe and sensitive enough to avoid triggering spasms, allow for self-controlled intensity of the stretch, and be easy to use with a setup time of under 1 minute. Our brainstorming process began with sketching ideas on a whiteboard and collaborating as a team. We then shared these concepts with Michelle and worked together to refine them. After discussing our ideas, we landed on one main concept, an autonomous calf stretching device that Michelle could use independently at home. Our inspiration came from existing wooden calf stretch boards on the market. However, we wanted to adapt and customize this idea specifically for Michelle's needs. Our design centers around a rotating foot platform with a fixed heel, which tilts upward to stretch the calf muscles. To achieve this motion, we developed a system using an inflatable air jack, similar to a balloon mechanism, to control the angle of the platform. We built and tested our initial prototype. While the core concept worked, testing revealed several areas for improvement. We quickly realized that using a hand pump was not ideal. It required too much effort and reduced ease of use. So we pivoted toward making the device more autonomous by replacing the hand pump with buttons that control the inflation and deflation of the airbag. We also experimented with different materials to determine what worked best in terms of comfort, durability, and functionality. Each prototype and testing session taught us something new, bringing us closer to a solution that truly meets Michelle's needs. In the end, we were able to develop a stretching device that helps Michelle stretch safely and independently. The device includes a built-in angle sensor that provides real-time data, allowing Michelle to monitor the intensity of her stretch. It also features an integrated timer so she can track the duration of each session. To ensure safety, the system was designed with a built-in safety valve to help prevent excessive pressure. By working closely with Michelle throughout the design process, we created a solution centered around independence, safety, and comfort. This is Team Michelle.